In this video, I am going to go through just some of the examples from sections 6.3, 6.4, and 6.5, and then we'll do the rest of them in class together. So this is a lot of just like arithmetic with fractions or decimals, some rules. So I'm going to just do a couple of these examples, and then I'll try to go slowly. So in number 1, we're adding fractions. To add fractions, you need a common denominator. And so what we're going to do is a common denominator would be their least common multiple, so 9 times 7. So multiply the top and the bottom here by 9, and the top and the bottom of this piece by 7. So you've got 9 over 63 plus 14 over 63. 9 and 14 is 23, so you get 23 over 63. When you are multiplying fractions, skipping to number 3 now, when you're multiplying fractions, you multiply straight across. So this would be 14 times 10 over 5 times 7. What you want to do here to make your life easier would be to simplify first if possible. So 10 over 5 is 2, and 14 over 7 is 2, so 2 times 2 is 4. Then, on number 5, we have a fraction subtraction over fraction addition as a fraction. So what we're going to do is get a common denominator on the top. So I'm going to multiply this by 2 to get me an 8 on the bottom. So I've got 6 over 8 minus 3 over 8. That is over, I'll multiply these by 2 as well to get a 6 as a common denominator there. So 5 6 plus 2 6. So 6 minus 3 is 3, so I have 3/8 on the top. On the bottom I have 7/6. When you divide fractions, you're going to flip and multiply. So we have 3/8 times 6 over 7. And then again, you want to multiply straight across. I'm going to simplify this first. 2 goes into 8 4 times, and 2 goes into 6 3 times. So I've got 3 times 3 on the top, which is 9, and 7 times 4 on the bottom, which is 28. Alright. Number 7, we are to write 15/20 as a reduced fraction, as a decimal, and as a percent. So the reduced fraction here, think about this. Okay, both of those have a 5 in common, so divide them both by 5. 15 over 5 is 3. 20 over 5 is 4, so 3/4 is your reduced fraction. If you wanted to, 3/4 I think we know is 0.75, and then to do that as a percent, you would just multiply by 100, so you get 75%. But if it was some fraction you didn't know, you could do it like this: 4 into 3, or 3 divided by 4, so you would get a 0.0 here. 4 goes into 37 times. 7 times 4 is 28. You get a 2 here, and then you would pull down another 0. 4 times 5 is 20, so you get a 20 here and then a 0. You put your decimal here right over where it goes, and so you get 0.75 as the decimal. And then again, multiply that by 100 to get the percent. We'll do number 8 together. Number 9, 2 other fractions equivalent to 5/7. So just multiply by something else. So multiply by 1, right? So just a particular one. So 5 times 2 is 10. Sorry, I can't see that. And 7 times 2 is 14. You can do 5 over 7 times 3 over 3. That would be 15 over 21, which would work also. How do you know that two fractions are equivalent? If their reduced versions look the same, right? Or their decimal representation would be the same thing, right? Okay, so 36 over 42, is that equivalent to 42 over 49? And how would we know? Okay, so 36 and 42 have, we could take we divide both of those by 6. What's 36 over 6? It's 6. What's 42 divided by 6? It's 7. 42 has a 7 and so does 49. So 42 over 7 is 6. 49 over 7 is 7. So those are equivalent. What about 5/8 and 34/56? Okay, so 5/8 is already reduced. So we would be looking for an 8 on the bottom. To get an 8 on the bottom here, we would need to divide this by 7. 7 times 8 is 56, yeah. But 7 doesn't go into 34 evenly. We would need it to be 35, so these are not equivalent. Okay, so the next thing is an irreducible square root. So problems that start with radicals, we are going to simplify these radicals, these square roots, into, like we're going to look for any perfect squares sitting inside of there so that we can factor them out. So what I do is I basically do like a factor tree. So this is 28 and 10. This would be 4 and 7. And that's a perfect square, so that's good. 10 is 2 and 5, and you can't go any further. And so this is actually equal to the square root of 4 times the square root of 7 times the square root of 2 times the square root of 5. The square root of 4 is just 2. And then 7 times 2 is 14 times 5, or let's do it the other way. 2 times 5 is 10, times 7 would be 70. So you would write that as 2 times root 70. Yeah. Let's do another one just to, okay, so we don't like fractions, so what we would do is to split that up, so you can basically distribute the square root to the top part of the fraction and the bottom part of the fraction. And then what you're looking at on the bottom, that's just 6, right? Square root of 36, and so you can leave your answer as root 5 over 6. Okay, now number 15 is a little messy. I'm going to zoom in here so we have some space. Okay, so we're going to do the same thing we did up on whatever number this was, 11. We're going to do the same thing that we did there. We're going to simplify each of these square roots. So I look at this and I see 9 times 5, which is good, because that's the square root of 9 times the square root of 5, which is 3 times the square root of 5, right? Because the square root of 9. Okay, I look at this and I see 8 and 10. That's 4 and 2. That's 2 and 5. So I actually have these together give you 4, right? So you have root 4 times root 4 times root 5. So that's 2 times 2 times root 5. So that's 4 root 5. And then we're adding it to 3 root 5, right, coming down from here. So that would be 7 root 5. You're going to add like terms, so the like terms here would be the 3 and the 4. That root 5 just hangs out, like you would add 4, think about it like you would add 4x and 3x, and you would get 7x. It's the same kind of thing. Okay, I think that's all I'll do in this video, and we'll do the rest of it tomorrow in class and do any of those parts slower that we need to. If you guys have any questions, let me know.